Neuralink, 2025, Mind Control or Medical Breakthrough, Decoding Neuralink's Core Promise. When most people hear Neuralink, they think of Elon Musk's futuristic vision of mind-reading technology or human-AI symbiosis. But behind the flashy headlines, Neuralink is fundamentally about brain-computer interface as a field that seeks to connect the neurons in your brain with external devices. In simple terms, BC is read electrical signals from the brain, interpret them, and then translate them into commands for a computer or prosthetic device. The ultimate goal: restore lost function and, perhaps someday, expand human capabilities. At the heart of Neuralink's system is the N1 implant, a tiny chip with ultra-thin electrodes, finer than a strand of hair. This implant sits in the brain and records the activity of neurons with high precision. To insert it safely, Neuralink developed the R1 robot, a surgical system designed to delicately thread electrodes into brain tissue without damaging blood vessels. Together, the N1 and R1 represent an attempt to overcome a key challenge in neuroscience: how to interface with the brain at scale, with stability and safety. Beyond the hype, the foundation of Neuralink's work lies in well-established neuroscience. Neurons communicate using small electrical impulses. If we can reliably detect these patterns and, in some cases, stimulate neurons with precise pulses, we can build a bridge between thought and action. That bridge is what Neuralink promises: to turn the abstract language of neurons into something we can use to restore mobility, perception, and maybe one day, cognition itself. Miracle cures, current and near-future applications. One of Neuralink's most exciting ambitions is restoring lost function. Imagine a person with spinal cord injury who can no longer move their arms. By implanting the N1, their brain signals could bypass the injury and directly control a robotic limb, or even reactivate their own muscles via electrical stimulation. This isn't science fiction. Researchers in other labs have already demonstrated versions of this. Neuralink hopes to push it further by making the implants more reliable and scalable. Another avenue is sensory restoration. For example, someone who has lost vision might one day receive artificial signals delivered directly to the brain's visual cortex, giving them a form of sight. Likewise, hearing loss could be addressed by bypassing damaged auditory pathways. Neuralink is also targeting neurological disorders such as epilepsy, Parkinson's disease, and severe depression. Deep brain stimulation has already proven effective in treating some of these conditions. Neuralink's implants could, in theory, provide more precise stimulation and monitoring, opening new doors for therapy. So, what do we know from human trials and early results? As of late 2025, Neuralink has implanted its device in a small number of patients under FDA approval. Early reports show participants controlling cursors or robotic arms with thought alone. It's still highly experimental, and many challenges remain, such as long-term safety, electrode durability, and data interpretation, but the initial steps are promising. The slippery slope. Ethical dilemmas and risks. Of course, with great power comes great responsibility. Neuralink raises profound ethical questions that society can't ignore. First is privacy and data security. If a device can read your brain signals, who owns that data? Could it be hacked, sold, or misused? The idea that thoughts might one day be vulnerable to surveillance or exploitation is chilling. Then there's the prospect of cognitive enhancement. What happens if Neuralink moves beyond therapy and into designer brains? If some people can afford enhanced memory, faster learning, or direct AI integration, while others cannot, we risk creating a new layer of inequality. The divide between the neural elite and everyone else could reshape society in unsettling ways. And let's not forget technical failures and unforeseen consequences. Any implant carries risks of infection or rejection. A malfunctioning device in the brain is far more serious than a broken smartphone. Worse still, if the system were hacked or misused, the consequences could be catastrophic. Beyond the hype. The road ahead for brain-computer interfaces. Neuralink isn't the only player. Academic labs and companies worldwide are pursuing alternative BCI approaches, from non-invasive headsets that use EEG signals to optical and ultrasound-based techniques that don't require brain surgery. Neuralink's invasive model promises greater precision, but also comes with higher risk. Regulation will play a huge role. The FDA and global health authorities will need to balance the push for innovation with the need for rigorous safety. Public perception matters too. Many people are uneasy about brain implants, and gaining trust will be as important as technical progress. The long game is sobering. While Neuralink has made remarkable strides, truly mainstream applications are likely decades away. Building a stable, safe, and mass-produced brain implant is vastly more complex than designing a smartphone. Yet, step by step, the path forward is being paved in it, but by the broader BCI community. The future is now. Personal choice and societal impact. Ultimately, Neuralink forces us to confront a fundamental question. Do we want this future? For individuals, the promise of restored mobility, vision, or freedom from neurological disease is life-changing. For society, however, the integration of minds and machines could reshape what it means to be human. Governance, ethicists, and the public will need to play an active role in shaping this neural future. Policies must protect privacy, ensure equitable access, and prevent abuse. Without careful guidance, we risk opening a Pandora's box of unintended consequences. So, is Neuralink 2025 a story of mind control or medical breakthrough? The truth is, it's a bit of both. The medical potential is real and extraordinary. But the ethical dilemmas are just as profound. Whether this becomes the dawn of a new human era, a cautionary tale will depend on the choices we make today.